So now we'll take a look at our first data type, which is the integer. The integer is a number. This number can be a Boolean data type, which is 4-bit. It can be a byte, which is 8 bits. Short integer, 16 bits. Integer, 32 bits, which is the most common that you'll be using. And a long integer, 64 bits.
Do me a favor. Will you say that unsigned long integer number for me real quick? I'll give you $50. I'm kidding. I'm not going to pay you. Look how big that number is.
Okay.
Do you
How
even
about
know?
this? I got it.
You
Ready?
got it? Okay.
18 446
No!
No, hold on. 073 709 551 615 E minus 18.
You are a cheating. All right, I'm sorry. I interrupted you.
You didn't say I couldn't use scientific notation. So most often you'll use the 32-bit integer, but in some circumstances you're going to use the long integer. There's no decimal place, there's no precision point in integers. It's just a whole number.
And the floating point is the opposite, I suppose. It's a rational number, or a real number in mathematics. It could be floating point, which is a 32-bit number, usually accurate within 6 or 7 significant figures. So in this case, if we have 2/3, you would have this many decimal places. 64-bit floating point typically is called a double, which is usually accurate within 15 significant figures. So 2/3 as a double would store this much precision. And some languages support a more advanced floating point, which is a decimal. Now this is sometimes between 96 and 128 bits. So you can see how much more precise that this number is. And even though this doesn't look like a lot, you look at the float and the decimal. Let's say if you were shooting a rocket towards the moon and you were using floating point numbers, by the time that you got to the moon, that offness and precision could actually have you missing the moon at that distance.
Or like completely missing the moon by 4 moon lengths back.
Yeah, exactly.
No.
So precision, especially when you're dealing with science, and it's extremely important.
Yeah. Well, you have to consider that when the shuttle docks with the space station, for example, that's like throwing a baseball from New York to like a basketball-sized hoop in France and hitting that target. I mean,
right.
It's crazy.
You have to be very precise. So maybe the decimal's not even precise enough.
Yeah. And the next is the character data type. So the character data type is just a single letter. Generally in ASCII, this is 8 bits, and Unicode is 16 bits. ASCII will give you the range of 0 to 255 and includes the standard characters like lowercase a through z and uppercase a through z, a white space, new line, tab, tildes, those kind of things. In Unicode, depending on the standard, you'll have some other types of characters and symbols like the strange mu symbol or the, whatever.
Yin.
Yeah,
that kind of thing. Yeah,
there's strange Hebrew symbols that I have no idea what they're for.
Yeah, and why they're like when you go to Microsoft Word and you go to symbols, why is it the first thing you see?
Yeah, it's like A B C D E F star, David. Where did that come from? Oh, well, that's cool.
I mentioned strings as primitive data types. In some languages, technically, strings are not a primitive data type. They are a composite data type. But some languages like Perl, TCL, strings are primitive data types. So in languages that support strings as a primitive data type, it is just simply a sequence of characters. So this sentence here, this is a string. You can see those are just characters put together as one sentence, and that's just what a string is.